Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to discuss about important point related to unit number 1, power system stability. The name of the topic is dynamics of synchronous machine. Now let us consider the kinetic energy of the rotor of a synchronous machine is kinetic energy equal to half into J into omega Sm square into 10 raised to minus 6. The unit for kinetic energy is in megajoule. Consider this as a equation number 1. Now here if you see, we will get two new parameters or two new things. First one is the J and second one is nothing but omega Sm square. Now what is J? J is the rotor moment of inertia and unit for J is kilogram meter square. Whereas this omega Sm, this omega and S stands for synchronous speed, M stands for mechanical radian per second. So we can say omega Sm equal to synchronous speed in mechanical radian per second. Now electrical speed in radian per second depends on number of pairs of a pole. We know that in the machines we already discussed relationship between electrical and the mechanical parameter. Theta E equal to P by 2 into theta M. So this is the relationship between electrical angle and the mechanical angle. So we will apply the same for electrical speed. Here we will get omega S will be equal to P by 2 into omega Sm. So mark this as equation number 2. Now here this omega S is nothing but what? Again it is a synchronous speed, but it will be in electrical radian per second. Initially in equation number 1 we have omega Sm square which is synchronous speed only, but it is in mechanical rad per second. And here in equation numbers 2 we got omega S same synchronous speed, but it is represented in electrical radian per second. Now we will put this equation number 2 in equation number 1. Before that, from this equation number 2 I can write like this: omega Sm will be equal to 2 by P into omega S. Now here in place of this omega Sm I will put this value as 2 by P into omega S. So what I will get? I will get this equation as 1 by 2 as it is. J term will be as it is. In place of this omega square Sm I will put this 2 by P square and omega S square, because we have omega square Sm, into 10 raised to minus 6. It will be as it is. Mark this as equation number 3. Now what I will do, I will take 1 omega S as a common here from this. So from this omega S square, if I take omega S common, whatever equation we will get, this equation will be treated as a one constant. So this is the same equation as that of a previous one. Here if we see, whatever term which is shown here in the bracket, it is nothing but moment of inertia. The unit of moment of inertia is megajoule second per electrical rad. So this is equation number 4, and we will represent this equation number 5. This is the equation of moment of inertia. So if we put this 5 in a 4, what we will get? We will get an equation of a kinetic energy, and that will be equal to half into M into omega S. Now let us consider one important parameter which is called as the inertia constant, represented by H. Now it will give the relationship between rating of the machine and the inertia constant M. How it will give a relationship? Here kinetic energy equal to half into M into omega S, which is equal to G into H. Where if we see, G is the rating of the machine, the unit for this is MVA, and H is nothing but inertia constant, whose unit is megajoule per MVA. Now why the unit of inertia constant is megajoule per MVA? From this I can write one formula. We know that kinetic energy equal to G into H. Here we got this relation. So from this I can write H will be equal to kinetic energy upon G. What is the unit of kinetic energy? Already we discussed, it is megajoule. What is the unit of G? It is MVA. So that's why the unit of H is megajoule per MVA. Now from equation number 6 we can write M equal to 2GH upon omega S. Now in place of this omega S we can write it as 2 pi F. So we will get m equal to gh upon pi f. Remember, the unit for this is megajoule second per electrical rad. Treat this as a equation number 7. Now what we will do, we will convert electrical rad to degree. We know that what we have to do, we have to multiply by pi by 180. So pi will get cancelled and we will get m equal to gh upon 180 f. Consider this unit as a megajoule second per electrical degree. Now if we have g as a common base, then what we will get, how we will calculate the value of m? We will get the value of m as just what we have to do, just we have to multiply it by 1 by g. So gg will get cancelled, you will get h upon pi f. Similarly, this equation number 8 also we can write it as m per unit equal to h upon 180 f. This is what is dynamics of synchronous machine. Thank you for watching this video.